Students, this is your last topic from the chapter determinant, and this topic is consistency of three linear equations in two variables. So let us make a set of linear equation with two variables and three equations. So a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0, and a3x plus b3y plus c3 is equal to 0. So this is a set of linear equation in which number of variable is 2 and number of equation is 3. So students, a very important thing, during examination don't get confused with this and Cramer's rule. Okay, remember, in Cramer's rule the number of equation and number of variables are always equal, but in this type of question number of variables and number of equation are not equal. So now let us write the condition for consistency. For that, let us consider a determinant D formed by taking the coefficient of x, coefficient of y, and the constant terms. So a1, a2, a3. First, in first column write the coefficient of x, in second column write the coefficient of y, and in third column write the constant terms. Now the value of this determinant will help us to check either this system of linear equations are solvable or not. So first note, number one, if this determinant value is not equal to 0, means if the value of determinant is somewhat 1, 2, 3, 4 or anything, but if the determinant t is not equal to 0, then the system is inconsistent. Okay, if the value of this determinant is not equal to 0, then you can say that this system of linear equation is inconsistent, or we cannot get the value of x and y. But number 2, if this determinant t is equal to 0, two cases may appear, number 1 and number 2. In first case, if column 1 and column 2 are identical, or column 1 and column 2 are multiple of other, and in case 2, if column 1 and column 2 are neither equal nor one is a multiple of another. So here, if this determinant value is equal to 0, then two cases may arise. Okay, in case 1, column 1 and column 2 are identical, means these two columns are same. So in that case, the system is again inconsistent. Okay, so if the column 1 and column 2, that is the coefficient of x and coefficient of y, are equal or same, then you can say that the system is inconsistent. Again, if one column is a multiple of other, then also the system is inconsistent. But if this value of determinant is equal to 0, and again this determinant, this column 1 and column 2 are independent of each other. Okay, independent means this column 1 and column 2 are not identical, or column 1 is not a multiple of column 2, as well as column 2 is not a multiple of column 1. So in that case only system is consistent. So the necessary and sufficient condition. So necessary and sufficient condition for the system of linear equation consisting of two variables and three equations to be consistent is determinant D. The value of determinant D found by the coefficient of x, coefficient y, and the constant term. If this determinant is equal to 0, and moreover column 1 and column 2 are independent to each other, then only the system is consistent. Otherwise the system is inconsistent.